Hello, everybody. This set of notes is going to cover our 5.2 topic, which are similar right triangles. As a reminder, all of Unit 5 is going to be about right triangles. So the last set of notes we talked about, we did Pythagorean theorem, and that is when you know two sides and you are missing a third side, you can use Pythagorean theorem to find that third side. Similar right triangles are not quite the same, though we may have to use the Pythagorean theorem in there somewhere, but we're still going to be working with missing sides of triangles, not necessarily angle information, okay? So here, if you look, I've given you a right triangle. It's sitting on its hypotenuse right now, but it is a right triangle. It says, if an altitude is drawn from the right angle of a triangle to the hypotenuse, then the two smaller triangles formed are similar to the original triangle and to each other. Draw the altitude CD in the right triangle. So back in Unit 4, we talked about altitudes, and an altitude is going to go from a vertex. An altitude is going to go from the vertex of your triangle down to its opposite side, and it's always going to be perpendicular. So what I'm going to do is I'm going to draw my altitude from C down to the hypotenuse. I'm going to label this new point down here D, and because it is an altitude, it's going to hit that hypotenuse perpendicularly, okay? What happens is you have a large triangle that is now split into two slightly smaller triangles, and all three of these triangles, the small one here, I'll show you this, the small triangle here, the medium triangle here, and the large triangle that we started with, all three of these triangles are going to be similar to each other, okay? Now, there are three ways to see how sides correspond to each other, and the first way to do that is to draw our three triangles all oriented the same direction. So I've got my right angle, my right angle, my right angle. We've got our small right triangle here in pink, our medium right triangle here in blue, and then our large triangle here in this yellowy gold color. Okay, now I'm going to label these triangles D, B, and C. My medium triangle, this is A, this is D, and this is C. And then my large triangle, we've got A, we've got C, and we've got B. Now, I do want to show you the sides that correspond with each other. So AC over here corresponds to the hypotenuse of the blue triangle. Both of those are the same length. They are AC, okay? My small triangle doesn't have side AC. I have side CB here, okay? CB there is also CB in my small triangle. What else do I have? Ooh, I've got DC. DC is over here in my small triangle, and then I've got AB, I've got AD, and I've got DB, and I think that's it. So when you look at the three triangles drawn out individually, you can see that some parts of the small triangle are going to be the same parts, or they're going to correspond to a different part of my hypotenuse. For example, CB. It's the leg of the large triangle, but it's the hypotenuse of the small triangle, okay? So because of this, excuse me, we have three similar triangles. Now, this is kind of a pain to do every time, is to draw them out like this. So instead what we do is we set up a table. And the way that this table is set up is we are going to put all of our small triangle information in that first row, our medium in the second row. These are columns, not rows, whatever. And then our third in this column here, okay? SL stands for the short leg. LL stands for the long leg, and H stands for the hypotenuse, okay? So if you want to, compare these to the three triangles that we drew, it's a little bit hard to do, but our small leg of our small triangle, our short leg of our small triangle would be DB in this case. The long leg would be CD, and then the hypotenuse is CB. In my medium triangle, the small leg is DC, the long leg is AD, and then the hypotenuse is AC. And I want you guys to look here, CD, CD. And then lastly, I've got this stuff over here. The hypotenuse is AB. The small leg, or the short leg, this one's kind of hard to do, is CB. And then The long leg would be AC. And again, I'm going to show you, you've got CB here, CB here. You've got AC here and AC here. So you can kind of see how they like correspond with each other. Using the using the table is going to be faster. I'll show you how to do it. So the first example we have says use similar triangles to find the value of x. So notice that we had one large right triangle. We had an altitude that was drawn, and we know it's an altitude because it intersects at 90 degrees there. Okay, so what I'm going to do is I'm going to break this up into my small triangle, my medium triangle, and my large triangle. I'm going to highlight them the same way every time. You do not have to highlight them if you do not want to. So what we're going to do is we're going to fill out our table. Small triangle, medium triangle, large triangle, short leg, long leg, hypotenuse. So I always start with my small triangle. The short leg is always going to be this part down here, but I don't have a value there, so I'm not going to put anything in my table. The long leg is always going to be this side here, and it is x, so I'm going to put x where the long leg goes. Whoops. And then the hypotenuse, the side across from the right angle, is 3. In my medium triangle, the short leg is also going to be x. Oh no. I'm trying to erase without erasing everything. Sorry if this is annoying. Boop, boop. Yay. Okay. My long leg, I do not have a long leg, but I do have my hypotenuse, that is 4. And then in my big triangle, my short leg is 3, my long leg is 4, and my hypotenuse is 5. Now, the way that I'm going to use these similarity pieces of information is I'm going to set up a proportion, because as we remember back in Unit 4, we learned that similar shapes are proportional. They have proportional side lengths. So I'm going to figure out my proportions, and my table actually just does that for me, okay? What I have to do is I have to match up, like, I'm gonna show you the proportion, like I'm gonna circle things so that you can see it while I'm talking about it, because I don't think I explained this very well, but visually you'll see what I mean. So notice that my small triangle includes both the long leg and the hypotenuse. My medium triangle does not include the long leg and the hypotenuse. It includes the short leg and the hypotenuse. So I can't use the long leg and hypotenuse of the small triangle with the short leg and the hypotenuse of the medium triangle. But if you look at your large triangle, the large triangle also has the same 2 parts. It has the long leg and the hypotenuse. So I can actually go ahead and set up my proportion like this. The other way that I could set up this proportion is I could use my small leg and my hypotenuse of my medium triangle, and I can combine it with the small leg and the hypotenuse of the large triangle. So we would have x over 4 equals 3 over 5, okay? Any way that you do this, you are going to get x is equal to 12 over 5. No matter if I do it the green way or the pink way, I'm going to get 12 over 5, okay? So that is how we use our tables to help us set up proportions with our similar figures and solve. So let's do this one over here. Oh, y has gone away. All right, so we've got our small triangle, our medium triangle, our large triangle, our short leg, our long leg, and our hypotenuse. This is my small triangle, this is my medium triangle, and this is my large triangle, okay? All right, so when I look at my small triangle, I have the short leg and I have the hypotenuse. That's supposed to be a Y. I do not have the long leg. In my medium triangle, I do not have my short leg, my long leg, or my hypotenuse. I don't have anything. So I'm going to leave that whole column blank for now. And then in my large triangle, the short leg is Y. I don't have the long leg, and then I know that the hypotenuse is 9. And so this one is just already set up for me. So I have 3 over y equals y over 9. That's going to be y squared equals 27. We're going to square root both sides, and we get that y is going to be 3 root 3 for that. So that is how we use our tables to set up our proportions. Example 3. Short triangle, medium triangle, long triangle. I always say these wrong. It's supposed to be small, medium, large triangles. This is short leg, long leg, hypotenuse. Okay? Now, what we are focusing on here is we are focusing on the roof of this shed. Okay, it says the figure shows the side view of a tool shed. What is the max height h of the shed? Round answers to the near 10th. So I'm really only focusing on the top triangle, that roof. It is split into my small triangle and my medium triangle. Okay. Now, I do need to know that the hypotenuse of the large triangle is 17, and I'm getting that from the width of the shed, okay? Now, when you look at the shed itself, it tells you that H is going from the tip of the roof all the way down to the bottom. I already know this much of the height, it's 9. What I need to figure out is this piece here. That's going to be the remainder of the roof that I need to add on to the 9 feet that I already have. That little apostrophe that you see means feet, by the way. Okay, so when I look at my small triangle, it looks like I've got the long leg and the hypotenuse. I don't have the short leg. The short leg is always located here on that side. In my medium triangle, I have the short leg. It's X. I do not have the long leg, but I do have the hypotenuse, so I can't stop right there because I don't have enough information. And then when I look at my large triangle, we've got 8, we've got 15, and then we've got 17. So I have a lot of the same information, so I'm just going to grab these two pieces to set up my proportion. I've got x over 8 equals 15 over 7. Let me pull up my calculator here because I do need a decimal for this. All right, so we've got 15 times 8 divided by 17. That answer is X. Now, as a reminder, I want to move you. Okay, as a reminder, that's just this bit. I still have to go back and add to it the X that I found, the 9 feet that the shed is from the bottom of the shed to where the roof starts, okay? I'm going to leave my decimal like I have it, that really long decimal, because I don't want to round to the very end. If I round now and then I round again, I'm getting further and further away from exact form. So I'm going to leave my decimal like that. And then I'm going to add the 9 feet that are at the bottom part of the shed. And I'm going to get a total height of my shed as 16.1 feet. It said round to the near 10th, so that is me rounding to the near 10th. And I'm going to say go away. All right. Example 4, small, medium, large, short leg, long leg, hypotenuse. Okay, you are designing a diamond-shaped kite. You know that AB is going to be 38.4 centimeters. You know that BC is 72 centimeters. And AC, so this long piece here, will be 81.6 centimeters. You want to use a straight crossbar, BD. About how long should it be? Okay, so here we have, I'm going to use this right over here. Here we have the right triangle that we want, okay? It has been split into its medium and small triangles as well as a large triangle itself. I'm supposed to be finding this. I'm supposed to be finding this crossbar length here, okay? Now, in a kite, which I know you probably don't just know this information, but in a kite, okay, these two lengths are going to be the same. So once we find from the center of our kite to B, we can just double it to find the entire crossbar BD. So that's what we're going to do. Looking at my small triangle, that pink one, I don't have the short leg, but I do have the long leg, and I do have the hypotenuse. In the medium triangle, it looks like I have the short leg. I do not have the long leg, but I do have the hypotenuse. And then in my large triangle, I've got 38.4 as the short leg, 72 is the long leg, and then the hypotenuse is 81.6. We have a choice in how we want to set this up. I'm going to use these two down here. Just as a reminder, you can also use these two if you want. So I'm going to say x over 38.4, that's going to equal 72 over 81.6. Let me grab my calculator, excuse me. Grab my calculator and get it. Give me the calculator. All right. 72 times 38.4 equals, divided by 81.6. And that's going to equal this really long decimal. But as a reminder, excuse me, as a reminder, this x only gives me half of that crossbar. So what I need to do is I need to multiply that number that I got by 2 to get the entire length of my crossbar. So the length of my crossbar BD will be 67.8 centimeters. That is being rounded to the nearest tenth. Okay. Okay. Excuse me. Go away. No, go away. Okay. Last example, because it's just the same thing over and over and over again. We got small. We got medium. We got large. We got a short leg. We got a long leg. We got hypotenuse. Okay. To find the cost of installing a rock wall in your school gymnasium, you will need to find the height of the gym wall. You use a cardboard square to line up the top and bottom of the gym wall. Your friend measures the vertical distance, so up and down, from the ground to your eye as 5 feet. And the distance from you to the gym wall is 8.5 feet. Approximate the height of the gym wall to the nearer tenth of a foot. Well, if we look at this picture, hopefully you can see that from here to here is what we don't know. That's W feet. But I do know that from this point right here to the bottom of my wall is 5 feet. So I already know part of the height of my wall, okay? So what I need to do is I'm going to do this in, no, see, that doesn't look good. Okay, I'm going to do this in this color here. So here's my large triangle. I've got my small triangle here, and I've got my medium triangle here. Gross. That's good enough. Okay, I'm going to use that information and fill out my table. So I've got 5 feet and 8.5 feet. I don't know the hypotenuse of my small triangle. I'm going to say short triangle. The short leg is going to be 8.5, and the long leg is W. Oh, and I'm done. Well, that was easy. All right. Okay, I need my calculator again. All right, so I've got 8.5 times 8.5 divided by 5. So that gets me from, remember that that's not the full width of the wall or the full height of the wall. That gets me this. So I still need to add my 5 feet to that. So I'm going to take that 14.45 and add 5 to it. And the total height of my wall, so the total height of my gym wall will be 19.5 feet. It says round to the near 10th. And so that is where I have rounded to. That is the near 10th. Go away. Okay. Anyways, that is all that I have for you on your notes today. If you have any other questions regarding these notes, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Adios. No, I don't like that. Bye. Go away.